This lecture will talk about the pins to the Arduino. The pins are the connections to the outside world. The main connections to the outside world are through these pins. Pins are basically just pieces of metal that come off the leads, pieces of metal that come off the microcontroller that you can connect to other devices. And they can be inputs and outputs and so on, and these are the main interface. So we're going to talk about these pins and how you control them through the sketch and how you observe them through the sketch. So we've got a picture of the Arduino here. It's got several pins. Now the pins, actually we're looking at, this isn't the whole picture, but this is most of it. The Arduino board itself has 2 rows of pins. The regular Arduino Uno, it has 2 rows of pins, a row on the top, you can see that row on the top, and then a row on the bottom that you actually can't see in this image. So those are the rows of pins on the board. Those pins on the board are connected to the pins, to the leads on the chip. So if you look at the microcontroller there, circled in red, you can see a bunch of leads, metal leads of the chip that are circled and highlighted. Those are the leads of the chip that are connected to those holes in the board. So they are wired directly to those holes through traces inside the board. So if you want to access the outside world from the microcontroller, the way you do it is you take a wire and you plug it into those holes on the board. Those holes on the board are connected directly to the pins, to the leads of the microcontroller, and your code can then control the pins and observe the pins. So pins are wires that are connected to the microcontroller. They're the main interface. Now there are other interfaces, right? There's the USB and so forth. But the main interface when you're building one of these IoT systems is through the pins. So all the other components in the system, or most of the other components in the system, will be connected to the Arduino board through those pins. You'll wire them to the pins. The voltages on the pins can be controlled by the sketch. If it's an output pin, which we'll talk about in a second. So you can control the voltages through a sketch. You can call a function inside your sketch. It will set the voltage on the pin. And pin voltages can be read by a sketch. So that is, if something else is controlling the pin's voltage, you can read what that voltage is inside your sketch. So pins can be designated as output pins or input pins. An output pin is controlled by the Arduino, so the voltage is determined by your sketch. So your sketch calls a library function which sets the voltage. Other components can be controlled through these outputs. So say you want to take, like here, an LED. Take an LED, you want to connect that to an Arduino. You will wire the 2 leads of the LED to the pins of the Arduino. You'll probably use a resistor in between, but I'm not drawing that right now. But you can wire the leads of the component to the Arduino's pins, and then you can write code inside your Arduino, write a sketch that assigns voltages to those pins and does something to the LED, presumably turns it off and on or makes it blink or something like that. So that's what output pins are for. Output pins are for controlling other devices from your Arduino. Now pins can also be designated as input pins. Input pins are controlled by other components. So the outside component controls the voltage on the input pin, and the Arduino just reads the voltage. So in this way, the Arduino can receive input from the outside world. So this is how you connect sensors up to the Arduino. You take the sensor, you wire it to some of these input pins. The Arduino can then read the voltage and interpret whatever the data is that the sensor is producing. So in this case, we got a picture of a switch. Very simple. If we wire this up properly, this switch, if it's switched one way, actually this is 3-state, but say it's a regular switch, it just has 2 positions, on, off. So we could wire a circuit so that if the switch was switched one way, that a voltage, maybe a 5 volts would appear on one of the pins. And if it was switched the other way, then 0 volts would appear. And then inside your sketch, you can detect if 5 volts is on the pin or if 0 volts is on the pin, so you can determine if somebody has flicked the switch or not, and write some code to do something appropriate. So input pins are for reading from sensors, where output pins are generally for driving actuators, right? You can drive a motor with it or something like that if it's an output pin. Now, pins can either be digital or analog. Now, we've mentioned what digital and analog are before, but in this case, we're talking about digital and analog in terms of voltage. Now, digital voltage, basically the difference between digital and analog, just to refresh your memory, digital is like integers, where analog is like real numbers, right? Continuous values. But digital is discrete, 0, 1, 2, so on. So in our machine, if it's a digital pin, the voltage can either be 0 volts or 5 volts. On an Arduino Uno anyway, and there are other variants of Arduino that maybe change that, but for Arduino Uno, it's 0 volts, 5 volts on a digital pin. Now, an analog pin can receive anywhere, usually 0 to 5 volts. Actually, you can change that range if you want to, but a continuous set of values anywhere in there. So some pins on the Arduino are digital only, can only act as digital pins, and they're labeled. So if you look at the Arduino board, one side of them it says digital. There actually, I believe it has 14. Yeah, pins 0 through 13. 0 through 13 are digital pins. So you can read digital inputs off of a digital pin. You can write digital outputs. So you can read input. You can act as an input and output as a digital line, and it's 0 volts or 5 volts. Now some pins can be analog. These analog pins, they're labeled A0 through A5, right? And they're on the other side. They're also labeled, clearly labeled on the Arduino board. These analog pins, you can read analog voltages. So if the voltage, whatever the voltage is, the voltage can be interpreted as a digital number. We'll talk more about that later. But the voltage can be interpreted and read by a sketch. And so the device can, your device can respond according to whatever the voltage is. And it can be an analog voltage. It's useful to read analog sensors. That's primarily what you use it for. So there are a lot of sensors that output analog information, so you need to read those. Analog-only pins are clearly labeled. No pins can generate analog output. So the digital pins can read digital input and drive digital output. You can drive zeros and ones by calling library functions of Arduino. But the analog pins cannot create analog outputs. They can read analog inputs and convert them to digital. They can read analog inputs, but they can't drive analog outputs. That's because we don't have a digital to analog converter inside the device. So now there is a way we can fake it using pulse width modulation, and we'll get to that in a later course. Thank you.